The fourth presentation on congestion monitoring in Nottingham using permanent count signs by DWASW Daladawatta. He's a civil engineer and has obtained his PhD and MSc at University of Nottingham, United Kingdom. Currently he is reading for his PhD at Daladawatta Defence University. His research interests include traffic engineering and construction project management. He is an associate member of the Institution of Engineers Sri Lanka, and at present he works as the project engineer of the Faculty of Engineering Building at Daladawatta Defence University.
Good afternoon, Dean of Engineering Faculty, the Conference Chair, Senior Officers, Academic Staff, and my dear ladies and gentlemen. I'm Flight Lieutenant Daladawatta. I'm here to talk about congestion monitoring in Nottingham using permanent count sites. First of all, let me introduce you the traffic in Nottingham. The traffic levels of Great Britain has increased over the past 60 years enormously. And the Department of Transportation has said that the traffic levels will increase by 35% compared to 2003 by the year of 2035. And this has threatened the safety of roads, environment, and the economic growth of Great Britain. And mostly city centres are affected by the congestion. And this has caused increased crash rates, longer time spent on roads, and delays increasing the prices of goods. And longer time spent on roads has caused increased fuel consumption and higher emissions of noxious gases. So therefore, Great Britain has introduced intelligent transportation systems in order to manage traffic. This paper is aimed at congestion monitoring using loop detectors. Now I'm going to talk about the mechanism of loop detectors. As you can see in the left-hand side picture, the inductive loops have been laid, and when there is a car passing by, there is a magnetic flux in the inductive loops. And when it feels there is a chunk of metal is moving over it, it counts. And it makes counts for each 5 minutes interval. And the present congestion monitoring system, which is used in Nottingham Traffic Control Centre, uses occupancy to classify congestion. And they are presented in congestion maps. As you can see in the right-hand side picture, you can see these data are being transferred to Nottingham Traffic Control Centre, and by the blue lines, blue arrows shows where the congestion is less, and the red arrow shows where the congestion is more, so the people can divert their traffic. So when the blue lines comes when the occupancy is less than 30%, the red lines comes when the occupancy is over 30%. And now I'm going to talk about methodology. Definition for congestion. A proper definition has not been created for congestion monitoring because it's a subjective area. Therefore, I have defined congestion into four areas, which is free flow, where no disruption of traffic, and the second one is stable flow, where the traffic is noticeably affected, and unstable flow, where the traffic queues begin to form, and the forced flow conditions, where jam concentrations occur. And then I checked for the accuracy of the permanent count sites. This was done by comparing the manual count data with the data collected from the Nottingham Traffic Control Centre, and then the results were checked. The manual count results were checked with the previous year's results, and after that it was checked whether the count sites data were valid or not. And then the analysis of permanent count sites were done. This was done by carrying out a spot speed survey using a radar gun, and it was checked whether the loop detectors were capable to do speed estimations. And then the time mean speeds for each 5-minute interval was compared with the loop detector data. And then space mean speed estimation was done, which is Vs is equal to QL over omega, where Q is the flow rate, L is the mean length of the vehicles, and omega is the occupancy. We can find Q and omega from the loop detector results, and we just had to estimate for the length. And then the congestion monitoring using space mean speeds was checked. Space mean speed versus other parameters were checked in order to see whether there was a representation of the links. And after we found, I found equations for each count site separately. And after that, relationships between fundamental parameters were found, which was checked for speed concentration, flow concentration, and for speed flow. The data collection was done at 2 specific points at Nottingham. One was at University Boulevard, and the other one was at Castle Boulevard. And it was checked for both east and westbound directions. It was done during the evening peak between 3 to 6 p.m. And at the University Boulevard, it was done on the 18th of July 2011, and at Castle Boulevard, it was done on 19th July 2011. The left-hand side diagram shows the University Boulevard count site. The right-hand one shows the Castle Boulevard. These loop detectors are embedded inside the road, so it doesn't object. The cars moving, so this doesn't affect the vehicle movement, unlike other methods. Data analysis. First of all, I'm going to talk about the time mean speed versus occupancy comparison. Occupancy and speed is inversely proportional, and the loop detectors are able to measure speed estimations of vehicles pass over them. Congestion monitoring using space mean speed and time mean speed. Time mean speed measured by the speed radar gun was higher than the estimated space mean speeds. The time mean speed is directly proportional to the space mean speed. Estimated space mean speed could be estimated to use as a traffic parameter for congestion monitoring. Space mean speed versus occupancy comparison. It was given inverse proportionality between occupancy and space mean speed as expected. Using the graphs, it was possible to estimate equations to monitor congestion using space mean speeds. So you can see the equations from the table below for 3 different loop detector sites. And then the speed versus concentration relationship was found. Space mean speed reduces as the concentration increases. A linear relationship shows it shows the road category. Free flow speeds occurred when the concentration is 0, and jam concentrations occurred when the space mean speeds reach 0. Free flow speeds and jam concentrations are indicated in the table below. And for University Boulevard eastbound, the free flow was 38 kilometers per hour, while the jam concentrations were 17. For Castle Boulevard East, it was 32.7 kilometers. Which I see, which is lacking in Sri Lanka, and after that, we should go for newer transportation methods, as we should publicize more public transportation rather than using vehicles. That is my main point, and that's what I'm doing for my PhD. I'm doing a demand analysis for monorails. As you can see in other countries, they use a lot of public transportation, although in Sri Lanka that is not happening. So I suggest Sri Lanka to use intelligent transportation systems. Although they are expensive, it might be cheaper in the long run. So that's the end of my presentation. Thank you so much.